In this short video, I'll be describing how to create a RF ground for your amateur radio station. We'll look at some of the materials we can use and why they're used, and some of the configurations we can utilize the material in to create a good station RF ground. We'll also be looking at a demonstration of why an RF ground is very, very important in real time. As we'll see here, there's a technique we can utilize called a star grounding system. And the star grounding system is exactly what it sounds like. In this illustration I made, you can see everything is tied to the tuner with the low inductance components tied to each part of the station. Here's a low inductance interconnect, a 2-inch piece of copper ribbon that's great from the tuner to the ground system itself. It has a slightly higher gauge of copper from Georgia copper that we'll look at shortly. This is another common technique. It's a more flexible material. It's a braided material. It doesn't quite have the same amount of low inductant properties that the copper ribbon will have, but what it makes up for, it is very flexible. And this is another very common material that is used. Well, back to the ribbon. This is some pretty heavy-duty ribbon here from Georgia copper, and I use it from the tuner to the ground stakes in the ground, 8-foot ground rods. You can see it's 0.022 inches thick, so it is fairly heavy gauge copper. The interconnects to the station are made with this 1-inch ribbon, and it's only 0.012 inches thick, so it's much more flexible and easy to work with using some shears to cut the proper lengths. So using the star configuration, we can take this and go from the tuner to every component in the station and creating our star grounding system. Here's just a side view of both of the copper products that I use. You can see the 1-inch compared to the 2-inch, and pretty self-explanatory on that. This is an interesting experiment with a field strength meter hooked up to my 280-foot loop. Notice the change in the RF voltage just by connecting a ground. This really is interesting. You can see how a RF ground really makes a big impact on the signal strength received. This would also have an impact on your overall signal-to-noise ratio. So when you're looking at the band or tuning around, you want the best signal-to-noise ratio possible. And so that could really have an impact on your overall reception. That's very important. Well, what we're looking at here is a real interesting product by MFJ. And this is also a really underutilized product. It's a pretty interesting tuner. And effectively, this can be used in situations that are less than ideal or even ideal. And it effectively cancels out some of the reactance in a ground system that can inhibit a good connection and good current to ground. When connected in series with your ground system, you have the sensitivity control, which will display the current, the inductance, which will change per band, and the capacitance, which will change per band. And you max the current out appropriately. Here's the connections on the back. You can see the input ground and output ground connections that are a bit lacking, but that's the way it is. So again, some really short demonstrations on RF grounding. The star configuration, very important, as seen here again. I always like to go from the tuner and then the low inductance component straps to each part of the station ground. This is amateur radio operator Kilo Alpha 0 Kilo Alpha 73.